Control valve is power-operated device used to regulate or manipulate the flow of fluids, such as gas, oil, water, and steam. It is a critical part of a control loop and is an example of a final control element. The control valve is by far the most common final control element used in the industry today. The control valves can be operated electrically, pneumatically, and hydraulically. A control valve receives a signal from a controller, such as PLC, in order for it to move, resulting in a change in the flow. Because the PLC signal is electrical, the control valve may require a device to convert the electrical signal so that it can operate. The control valve has two separate components, the valve and the actuator. Valve bodies are of different types or styles depending on device conditions, tapping light, and desired application. Two the classes of control valve are linear motion and rotary motion. On a linear motion valve, the stem in the valve movement is up and down. A common type of sliding control valve is the gate valve. A rotary motion valve, in almost all cases, rotary 90 degrees from open to the closest position. A commonly used rotary valve is the butterfly valve. The actuator is the device connected to the valve through the valve stem that provides the force required to move the valve. As we said earlier, the actuator can be controlled electrically, pneumatically, and hydraulically. The most common and the most reliable is the pneumatic actuator. The control valve receives a signal from a controller, such as PLC or DCS, in order to operate. The controller compares the actual flow rate to the desired flow value called the set point. The controller will produce an output to move the valve to bring the flow rate to the set point value. Because of how pneumatic actuators are built, a control valve will fail to a specific position when a loss of the control signal occurs. As the supply air pressure increases, the rubber diagram pushes against the spring and moves the valve stem down into valve body. As the supply air pressure is reduced, the spring will move the valve stem out of the body. The position to which the control valve is moved if a loss of signal occurs in the reverse to the fail-safe mode. The type of fail-safe mode depends on the application for which the control valve is used, and the actuator causes the valve to close in a while-closed control valve. The actuator causes the valves to open in a while-open control valve. In normal operation, the force of the spring must be overcome by the electrical or pneumatic actuator. In the event of a power failure, the actuator or pneumatic force is no longer present, and the spring pressure forces the valve to open. You might wonder how much the valve open or close when the flow rate changes. Well, it depends on a number of things, such as the percentage of flow rate change and the diameter of the pipe. The gradients and control must be tuned so there is produced the correct response to any change in the flow rate. This is most commonly achieved by using PID, which the PLC or controller. We have already several